Space elevators. One idea for a planet-to-space transit method is a space elevator. The major element would consist of a cable, sometimes known as a tether, that was attached to the ground and extended into space. Without the need for massive rockets, the concept would allow spacecraft to ascend the cable directly into orbit from a planetary surface, such as the Earth's. Due to the enormous weight, a simple tall tower supported from below could not be used as an Earth-based space elevator. Instead, a cable would be used, with one end tied to the surface near the equator and the other end attached to a counterweight in space outside of geostationary orbit, 35,786 kilometers altitude. The cable would be held up, under tension, and immobile over a single location on Earth due to the conflicting forces of gravity, which is stronger at the lower end, and the upward centrifugal force, which is stronger at the upper end. When the tether was deployed, climbers may release their cargo to and from orbit by repeatedly climbing up and down the cable using mechanical means. Konstantin Tsiolkovsky published the idea of a tower entering geosynchronous orbit for the first time in 1895. He suggested building a freestanding tower that would extend all the way from the ground up to geostationary orbit. Like all structures, Tsiolkovsky's would be in compression and sustain its weight from the bottom up. Since 1959, the majority of concepts for space elevators have concentrated on purely tensile structures, with the system's weight being supported by centrifugal forces from above. A space tether in the tensile notions extends from a substantial mass, the counterweight, beyond geostationary orbit to the Earth. Like an upside-down plumb bob, this structure is kept in tension between Earth and the counterweight. The cable thickness is tension-dependent, it is greatest in a geostationary orbit and lowest on the ground. Although there have been improvements in a number of areas, the idea is still just outside the realm of reality. The ongoing difficulties have led some scientists and engineers to the conclusion that a space elevator will never be constructed, at least here on Earth. The students claim that it is technically and financially feasible to construct such a lunar space elevator, which was first publicly described by Jerome Pearson at a conference in 1977 and by Yuri Arsutinov in a different paper published in 1979. Their findings were published in a study on August 25 on the online research archive R14. The 100,000 kilometers long tether might be the largest obstacle in the construction of a space elevator. To withstand the gravitational and centrifugal forces pressing on it, it would need to be extremely sturdy. For a space elevator cable, the steel utilized in big structures would not be suitable. A 100-ton climber space elevator is anticipated to be constructed by the year 2050. It is made up of a 12,500-ton counterweight, a 400-meter diameter floating earth port, and a 96,000 kilometers carbon nanotube cable.